This is the bottom of page 182. The previous video was the top of the page. This is the bottom of the page. So let's make a whiteboard and solve some problems here. Number 7 reads, contestants in a dance-a-thon rest for the same amount of time every hour. A couple rests for 25 minutes in 5 hours. How long did they rest in 8 hours? So our two different terms here, our units, are going to be minutes and hours. They're going to rest for 25 minutes in 5 hours. How long did they rest for in 8 hours? So make 8 hours be your second term. And this is going to be one where we need to find the unit rate, because you can't just take 8 hours and divide it and get 5 hours. You can't multiply 5 and get 8. They're not compatible terms. So we're going to simplify 25 minutes and 5 hours by dividing by 5. If you divide these by 5, which is a common factor, you would get 5 minutes for every 1 hour. And then if you multiply by 8, you would get 8 hours, which is what we're looking for. And you would get 5 times 8 is 40 minutes. So what's the answer? Go up to our line. How long did they rest in 8 hours? They rested for 40 minutes. All right, let's move on. We're on number 8. Number 8 reads, Francis gets 6 paychecks in 12 weeks. 6 paychecks in 12 weeks. How many paychecks does she get in 52 weeks? Do the same thing as I just did below. I'm going to simplify and work down, and then I'm going to work over to get to 52 weeks. I'm going to simplify by 6. 6 and 12 share a factor of 6. And I'm going to get 6 divided by 6 is 1 paycheck every 12 divided by 6 is 2 weeks. 1 paycheck every 2 weeks. And then how do I get from 2 weeks to 52 weeks? I look at my multiplication chart and multiply by 26. Half of 52 is 26, so 2 times 26 is 52. In 52 weeks, she would get, multiply 1 times 26, and we get 26 checks, 26 paychecks. Go up to our line, write 26 paychecks. All right, let's check out the last couple. We have a map here. I think I'm probably going to ditch my whiteboard. We have a map here for number 9. Number 9 reads, what is the actual distance between Gendit and Montrose? So if you look on the map here, Gendit is here and Montrose is here. And on the map it's a difference of 1.5 centimeters. But we're looking for the actual distance. In real life, each one of those centimeters is a distance of 16 kilometers. So what we do on a problem like this is we write our scale, which is right here, as 16 kilometers is 1 centimeter. And then I'm going to write equals, and I want to know the distance in kilometers of 1.5 centimeters. Now there are various ways to do this. One way to do this would be use mental math. You could draw a picture here, and I'm okay with this method. So 1.5 centimeters means 1 whole centimeter like this, and then another half a centimeter. So if I went like this and drew 1 centimeter, and then half a centimeter, then I could use mental math to figure out 1 centimeter is 16 kilometers, and then a half a centimeter would be half of 16, which would be 8 kilometers. If you add those up, you're going to get 24. That's one way to do it. It's not the only way. It's a different method that we've been showing. So I'm going to write 24 kilometers. The method we've been showing here was, I'll go back to my ratio. How do you get from 1 to 1.5? Well, we talked about this earlier. 1 times anything is that number. So if I multiply by 1.5, 1 times 1.5 is 1.5, so I have to multiply this by 1.5. I'm going to do this up here in the white space up here. If I do 16 times 1.5, 5 times 6 is 30. 5 times 1 is 3, or 5, plus 1 is 8. And x is 0, 1 times 6 is 6, and 1 times 1 is 1. You're going to get 0 and 14 and 2, and then you got to move your decimal over one place, and so you get 24 kilometers. Alright, number 10 reads, how do you solve problems with proportions? So there's two different ways. The first step, though, is that you need to set it up as equivalent ratios. And there's two different methods. The top of the page, we set it up as equivalent ratios, and one term went into the other term, so we just multiplied. Other times you have to simplify. So I'm not sure the best way to write this, but I'll do my best. It says set it up as equivalent ratios. First check if one term divides evenly into the other term. If not, simplify to the unit rate. Alright, I realize that's a little bit messy. I probably should have typed it, but too late now. So, here's what I wrote. Set it up as equivalent ratios. First check if one term divides evenly into the other term. If not, simplify to the unit rate. Alright, well, great job. You're done with page 182.